Hey guys, welcome to another lecture in Precalculus. Today we're going to start stepping it up and we'll be talking about the slope-intercept form. So one of the advantages we discussed earlier with graphing lines is so that we can find a general solution and be able to pick out values here and there from the equations. So today we'll be exploring how do we graph things and see the behavior visually um, using the slope-intercept form. And the slope-intercept form is going to help you just graph things way faster. So before that, let's talk about this word intercept. This word intercept. So at the intercept comes in two intercepts. There's the y-intercept, y-intercept. The y-intercept has its own special letter that we usually denominate with b. And there's also an x-intercept, which I'll get into in a second. So all the y-intercept is at what point does the line, say we had some line like this, so say what point does this line cross y, the y-axis? So at what point does this line cross the y-axis? So you see the point is right here. That's where it crosses the y-axis. So that's all the intercept is, but it's really what is the value of y when x is equal to 0? X is equal to 0 because the y-axis is on x is equal to 0, right? And the x-axis is on y equal to 0. So the question is, what is the value of y when x is equal to 0? And that value is b. So that is the y-intercept. So in this case, at x is equal to 0 right here, the value is 1.5. So this is 0, 1.5. And this right here is b, the y-intercept. So it's the exact opposite for the x-intercept then. The x-intercept usually doesn't get a fancy letter, and the x-intercept is at exactly what value of y equals 0, exactly what is the value of x when y is equal to 0. So what is the value of x when y is equal to 0? So in this case, the value of x when y is equal to 0, or when the line crosses the x-axis, looks around like minus 1.25. So minus 1.25 and 0. And so that is what an intercept is. So we'll be using this to study more about um, so let's go down. So first, how do we find this y-intercept form? So what are the three things that we know? So we have m is equal to slope, and the formula for this, if you guys remember, is y2 minus y1 over x2 minus x1. So rise over run. How high it goes by how far across it goes. That's simply what slope is. And we also know that we have at some y-intercept b, it goes 0 and b, right? So what is the value of y when x is equal to 0 at some arbitrary? And we also have, let's say, some arbitrary point on the graph xy. So let's plug these into the equation. So we have y2, y2 being y minus b over x minus 0 is m. And let's now solve for y. So we have y minus b over x equal to m, and we have mx y minus b, and then we have, I'm just going to swap these across, so let's do y is equal to mx plus b. And this right here, let's change colors, is the slope intercept form. And you'll see this a lot. So make sure you learn what this is. So this is simply expressing y, expressing the height, expressing the y point as a function of x given some property, the slope, and some property, the y-intercept. And these are all constants, right? These are constants. They're constants. Cool. So so now if we know the slope and the y-intercept, we can find the equation for any line given some graph. So let's go over some examples right now. So let me just get rid of all of this right here, and let's do an example. So let's say you're given some slope. Say you're given some slope is equal to 3/4, and some y-intercept. And from now on, I'm just going to write it as, I want you to write this in the slope-intercept formula. So what was the slope-intercept formula? We know that it is y is equal to mx plus b. So make sure you pause, give this a try. And since we know what m is, it's a simple substitution. And this would be plus minus 3. So 3/4x minus 3. And that is the equation. So let's go back up here. I want to use this graph. So there we go. Let me delete all the stuff we have right now. And let's say we're given some graph now. Say we are given some graph now. Let's do something like this right here. Whoops. Let's say something like that. And let's say this crosses that point right there, and it crosses that point right here. So now given this graph, I want you to find the equation of this line. So far we've been doing the opposite. So we've been taking the value of equations and mapping them to graphs. Now we can do the reverse. We can take equations out of the graphs. So the number one step we would do here is first we want to find, what do we want to find? The y-intercept. Find y-intercept. Find the y-intercept. And that's all we have to do is see where the graph crosses the y-axis, and that's the y-intercept. So right here, it crosses at 0, 3. Crosses at 0, 3. So then b is equal to 3. Awesome. So now let's find the slope. Let's pick some arbitrary points. So let's say right there at, this is 3, 1. Sorry, 1, 3. No, I was right the first time. It's 3, 1. This is 3, 1. And then this is 0, 3, which we already know. And let's find the slope. That's the next step. Find the slope. Find the slope. So let's find the slope here. So all the slope is rise over run. Rise over run. So how far down does this rise? Well, it goes down 3, so -3. And how much does it run across? It goes, sorry, not -3, it goes down 2, -2, and it goes across 3. So the slope is simply -2 over 3. So what's the equation now? All you have to do is just sub into equation. Sub into equation. So we have y is equal to mx plus b. So we know m minus 2 over 3. And we know b now, which is plus 3. And that is the equation for this graph. And now you can find the graph way out here, in the thousands, and all you have to do is just plug in the values. And there's a x here. Okay, awesome. Let's try another example now. So now I want you to write this example. I want you to write 2x minus 4y is equal to 6. 2x minus 4y is equal to 6 in slope-intercept form. So make sure you pause and give it a try. Okay, awesome. So hopefully you've given it a try, and let's start figuring out how to solve this right here. I don't know why I drew that. Let me erase this. And all we have to do is just get y by itself. We just have to isolate y, and then we're good to go. So let's move all the terms that aren't y across. So let's do minus 4y is equal to 6 minus 2x. And I want to get rid of the y. I want to get rid of the minus, so I'm just going to divide by minus 1. So you get 4y minus 6 plus 2x. And then all we have to do is divide by 4. So we have minus 6 plus 2x divided by 4. And if you simplify this, you get minus 3 over 2 plus half x. And if we rearrange this, we get that the slope is a half and the y-intercept is minus 3 over 2. Cool. So now we're going to do the exact opposite of what we did earlier. We're going to take some equation and use what we've learned to graph even faster than we used to be able to by, instead of finding those specific points and plugging them in, I'm going to show you a faster way to graph now. So let's say we want to graph. The question is, let's graph y is equal to 1 half x minus 4. 1 half x minus 4. So what's step number 1? Step number 1 is find the y-intercept. Find the y-intercept, or plot the y-intercept. So we know the y-intercept is minus 4. So the y-intercept occurs at 0, minus 4. 0 minus 4 is right here. Let's put a point there. And now let's use that intercept and the slope to find another point. So the slope is 1 half. That means let me write this down as a step. Use slope to find another point using intercept. Sorry for my writing. I thought I was getting better, but it's getting worse. Okay, so the slope is 1 half, which means it goes up by 1, the rise is 1, and it goes across by 2, run is 2. So it goes up by 1, goes up by 1, up to minus 3, and then across by 2. So this point, so we have 0, whoops, yep, 0 minus 4, and we have this point right here, which is 2 minus 3. And now all we have to do is just draw a straight line through it, through both points. Right there. I don't want to go off my graph. So we draw a straight line through those points. And that's it. That's how you graph something given a equation. See how much faster that is? Like normally what you'd have to do is just plug in arbitrary x and y values. But now we have this, we start at the center and we can work our way outwards. And now we can find the general solution for anything, right? Like I know all of the solutions from here, here, here. And we could even see the behavior that we see that this is starting from a really low point and rising upwards. So hopefully you guys have learned something and taken away how to graph fast. So what do we like? Let's summarize what we learned today then. So we've learned the slope-intercept form. We've learned what the y-intercept and the x-intercept are. We know how to find the slope and the y-intercept. And given that slope and y-intercept, we can find the equation of any line. We've looked at how we can find the equation from a graph, and we've figured out how to use slope-intercept form to find the graph. So hopefully you guys learned a lot. Make sure